Hello and welcome to Newsclick's International Roundup. We're going to discuss what has become a major issue for Boeing as their 737 MAX 8s have been grounded. Initially it was only a certain set of countries, in fact all the countries except the United States. As of now, even the United States, after President Trump issued some directives, has grounded the 737 MAX 8s. Raghu, what actually happened in this flight seems to be very similar to the Lions Air flight which had crashed a couple of months back, 4 months or 5 months back. Does this indicate the 737 MAX 8s now are going to see problems? They have about 5,000 already on order. Do you think this is a major, shall we say, crash of also Boeing as a consequence?
Well, it will have serious consequences in the short to medium term, definitely, because it's evident now that there is a design flaw in the 737 MAX,
which we are going to discuss,
series, which we will be discussing. And because it's a design flaw, unless it is properly rectified, checked, certified, which is a process which is not going to be less than 6 to 8 months, I would say, at a minimum, if you're going to get proper certification. And the certification will be done by different regulatory agencies in the US, in Europe, in other countries. Some countries will automatically, once the FAA certifies, they will certify. Some countries will do it independently. It's going to be a painful process for Boeing.
Also, this FAA, the Federal Aviation Authority, has not really covered itself with glory.
Not at all.
Because all others grounded it. It still allowed the 737 MAX 8s to fly. In fact, we had a senior figure in the in CNN studio who said, I am quite willing to fly, but I would not buy a ticket for my 3-year-old granddaughter. Now, it doesn't seem to show too much confidence, shall we say, in the Federal Aviation Authority as well.
In fact, the FAA for several years now has actually been taking advisories from the manufacturers, from Boeing, and basing their own certification on the self-certification by Boeing, which is obviously not a healthy practice.
For a regulatory agency.
For a regulatory agency, and that too for a regulatory agency as powerful and, we thought, strong as the FAA, that they would take their own steps to ascertain airworthiness of different designs and then only issue certification. A recent study has shown that FAA has accepted self-certification by Boeing for as much as 80% of aircraft features. And that's an astoundingly large figure.
Coming back to the actual issues, if we look at the Lions Air flight path, which is, you can see that after a certain point, you see instead of a steep climb, which is how the takeoff should have taken place, you see flattening.
That's right.
And this seems to be because the pilot and the flight control systems are fighting each other.
That's right.
Now, this has been, it has been argued, because of certain basic features of the Boeing 737 MAX 8 version, which wasn't there in their planes earlier.
Right.
This is something which has been introduced. Do you think that is actually perhaps the cause of what happened to the Lion Air flight as well as Ethiopian Airlines flight?
See, the Lion Air is absolutely certain. We already know all the facts about the Lion Air flight. There is still a little uncertainty about the Ethiopian airline until all the data
black
comes
boxes,
in. The black boxes plus the various other real-time data from the engine and from the aircraft which are being constantly monitored. It will take a little time for that to come in, but once that come in, I think we will see the pattern being more or less the same. What this clearly shows is that the aircraft is not being allowed to climb at its normal rate of climb. The sensor which gives a signal saying, look, you're climbing too high and this may lead to a stall, and then forces the aircraft nose down. So what you can see here is from the figure on top, you've got a rate of climb which the sensor perceives is too steep and thinks the aircraft is going to stall. And you can see from the bottom figure there that it then adjusts the trim to reduce the climb and brings the nose down.
So effectively the nose drops automatically because of this augmentation, what is called as a maneuvering characteristic augmentation system.
That's right.
Or the MCAS.
Yes.
This is adjusting the nose to actually drop if it thinks that this climb is too steep.
Right. But there's the additional factor is, it's one thing if the plane automatically adjusts the MCAS, gives a signal saying lower the nose based on an actual reading of a too high rate of climb. But what seems to have happened in Lion Air and most probably in the Ethiopian airline as well is that there is a faulty indication of the rate of climb.
That the sensor for the rate of climb was faulty.
That's
and
right.
In addition, it seems there is only a single sensor for the MCAS. Each MCAS had only a single sensor.
That's right. So whereas the aircraft is climbing at a normal rate of climb, the sensor gives an erroneous message to MCAS saying this is too high and lowers the nose. So then what happens is, because of all these problems that we've encountered, the pilot is not sure what is happening. He sees the aircraft nose being lowered. He then tries to raise it again. The system MCAS automatically lowers the nose. So there's a fight going on between the pilot and
tug of war takes place. Two things. It seems the Lion Air had about 12 such attempts to lower and raise the nose.
That's right.
The pilot trying to raise it while the MCAS was trying to lower it. So that seems to be what is there. The second part of it is, and I think this is a very important issue, that it seems the MCAS operates even when the autopilot is off.
Yes.
So under manual conditions also, the MCAS will dip the nose.
That's right.
And therefore it has to be separately switched off, not switched off directly if you switch off the autopilot system.
And that's where what we were talking about comes in, where the pilot is actually fighting with MCAS. Because MCAS is taking some steps, the pilot wants to correct that, and there's a wrestling match between them. And then the nose goes into a downward position. It enters a steep dive from which the pilot is not able to recover.
Now, looking at this issue, the problem seems to have been in the MCAS system. The people have pointed out two problems in the MCAS system. One is, of course, that if there's a faulty sensor, it is a single sensor, then the MCAS behaves badly. And the pilots then have to switch it off manually. Now, this is the other part, that switching off this system manually, the pilots were not really, it seems, either trained for it, nor is it a standard step in the operating procedure. What happens is, if it misbehaves, the pilots, if they're very experienced, know they can switch off the electrical trim, but it wasn't in any of the books, neither was a part of any of the directions, guidelines were given.
That's the most unfortunate part of this. This is not in the manual. There are training programs for pilots supposed to have been conducted. One doesn't know how effective these training programs are. Who is it being conducted by? Suppose an American airline does do a fair amount of training. Does that also apply to Ethiopian or to Lion?
Hold on, there is a bigger issue. Apparently, Boeing had said that this MAX variant of the 737s is very similar to earlier flights, earlier 737s. Therefore, the pilots did not need extensive training. And therefore, this particular modification which they had made was something that should have been what the pilots were trained for. They were not trained. And in fact, this was one of the major reasons why the airlines were more willing to accept Boeing 737's MAX versions, because they felt it was a very easy switchover, while there was a major change which had been made, which in both these cases were perhaps crucial.
That's right. And Boeing has issued an advisory
After
which
the
it
Lion
sends
Air
around
crash.
after the Lion Air crash. But then an advisory is a separate bit of document. It's not there as part of the manual. So unless the pilot is very conscious, he may not, especially in conditions of sudden malfunction or panic inside the cockpit, he may not refer to the advisory. He will look at the manual and see nothing there. That's one. Second thing is, we frequently hear references to the seniority of the pilots involved, that in the Ethiopian Air case, for example, that he had flown more than 8,000 hours. But if he had flown 8,000 hours on other models of aircraft and maybe a few hundred hours on the MAX, it doesn't necessarily train him to respond to these kinds of emergency situations.
And there have been also a lot of reference to an Indian pilot, which is the Lion Air case, Ethiopian pilots not the third world pilots being not so equipped. If this was a American pilot, it would have been different. The argument is the American pilots have a much larger ecosystem. They talk to each other, irrespective of the advisories and all. They know what to do in case of an accident like this. So that's the one case. But the bigger issue still remains, why was the MCS system introduced at all? And if you look at the aircraft, what used to be there earlier in 737 and what is there in the 737 MAX variant, we see the clear difference, and you can see the MAX 737 at the top and you can see the earlier variant at the bottom. And you can see the positioning of the engine. That this, what has been argued is, bigger engines needed it to be moved upwards and also had to be tilted a little. So that changed the flight characteristic, and because it was a different flight characteristic, it was felt that the pilots may actually stall the aircraft with the steep angle of attack, and therefore the need to put the MCAS. The real issue is that you are making the aircraft aerodynamically more unstable, and you are compensating with a control system modification. Now this is a fundamental issue. Should this have done for a passenger airlines, that would not it have been better to have actually redesigned the fuselage and the airframe in order to accommodate these changes, rather than this as a retrofit?
I would think so. We know that the CFN engine, the LEAP engine, which has been introduced in the 737 MAX as well as in the A320 Neos, has tried to bring about a 15% improvement in fuel economy. And this has been done apart from other modifications in the engine, essentially by increasing the size of the intake fan, which increases the diameter of the engine, which means clearly some re-engineering has to be done in the nacelle, the shell which holds the engine, which houses the engine, how it is positioned on the wing, etc. And it seems fairly clear now that Airbus seems to have managed this transition better than Boeing has. Boeing, it is known, has given a tilt to the engine and has raised the engine nose upwards, because the clearance between this larger fan and the surface of the runway was not as much as it should have been. So they have tried to compensate by changing this.
Boeing had a higher
That's right.
seams
and
wing.
this seems to have compelled pilots who felt that it was because of the size of and the larger weight of this engine, the aircraft had a tendency for its nose to go down, and the pilot therefore would compensate by raising the nose up, which may have triggered this stall warning.
MCAS.
Yeah, but because Boeing automated this MCAS response overriding the pilot, it brings about the situation where the pilot and the aircraft are battling each other.
So three sets of separate issues. One is a faulty sensor, a single sensor being used for the MCAS, the MCAS itself trying to correct for what was a instability introduced by a larger engine, and the third thing, not telling the pilots all of this, leaving him in ignorance about how the MCAS was operating, how it was operating even when they were in manual, and if there was a faulty MCAS, then they should switch it off, what is called switch off the electrical trip, which is not a normal procedure. Set, operate the cutout. Now that's not a normal procedure. It's not a switch that you do. So all of these three things actually combined in this particular case, and really to me, apart from anything else, not informing the operator, i.e. the pilot, is the key problem.
And added to this is of course the fact that an aircraft is at its most vulnerable during takeoff. And it is during takeoff that the angle of attack becomes a major issue in the aircraft, because that's when the nose is tilted up. Once it has reached cruise altitude, it's flying along merrily. It's precisely at this point that this vulnerability gets exposed. The pilot gets into a confusion about what's happening, and that's the most dangerous time.
Stalling of the aircraft during takeoff is the most dangerous part of the flight. That's what you're really saying. You know, this is also the commercial part of it. The reason Boeing was doing it, because they were feeling the pinch of Airbus 320 taking over a segment of their market, and they did not have an aircraft really which could go head to head with A320, Airbus 320. And therefore this short-changing, shall we say, the airlines, the passengers, whatever you say it, by a quick and dirty, shall we say, retrofit fix, or what if you want to call it, which does not really look at the fundamental issue, but tries to retrofit something onto the aircraft which it wasn't designed for initially.
Penny wise and pound foolish on the part of Boeing, because Boeing's, for saving a few months of design time, and in this race with Airbus, they have lost a lot more time, money and reputation in what's essentially a two-horse race in the aviation business.
Actually, with the so-called 5,000 orders, how much now deliveries will be asked for is an open question. And that means that we really are seeing a huge blow to Boeing, because this segment seems to be the most popular segment in terms of aircraft and airlines usage.
The only thing saving Boeing at this stage, I think, is the fact that the Airbus Neo has had its own share of problems with engine functioning, cutouts in the compressor stages, etc. But we can discuss that some other time. They seem to have recovered from it in most theaters across the world. But Boeing is now in serious trouble because all their aircraft have been grounded, which has never happened with Airbus.
And also, though, you know, if you see it, that two aircraft crashed in fairly quick succession.
That's right.
And that sort of puts a different complexion to the whole thing. And I think the reputation is also because information sharing and all of this didn't happen at the right time. Thank you very much, Raghu, for being with us. Thank you for watching Newsclick. Do keep watching our episodes on this and other issues.